Here we have a word problem where we chill a bottle of wine to 33 degrees Fahrenheit and bring it to the beach on an 88-degree day. So that bottle of wine that was 33 degrees, almost freezing cold, is only going to get warmer and warmer. The temperature should be going up as we're sitting there at the beach, unless we drink it really fast. The wine will warm to a temperature of capital T of T equals 88 minus 55 e to the negative 1.5 T. Degrees in T hours. So I don't love having the same letters, but we get our input and our output variables here. So you plug in time, lowercase t, that's in hours. Tell me how many hours it's been. It's not in days or months, it's just in hours. And we should be able to get out the temperature T, and this must be degrees Fahrenheit. If we're talking about 33 degrees for the wine on an 88-degree day. The first part says, find capital T of 0.6 and interpret the results. So we're going to do capital T of 0.6, which just means we're going to replace all the lowercase t's that we see with a 0.6 in parentheses. So we're just plugging into the original function. We're not doing any change problem yet. It's not asking for average rate of change or anything. We're just going to replace the t that's in this equation here, 88 minus 55 e to the negative 1.5 times our t is 0.6. So you might need to plug it in just like this in your calculator and find that E button and plug in. And we should get an answer that's higher than 33 degrees, right? Because it's been 0.6 hours. It's been over a half hour that it's been sitting at the beach. It shouldn't be 33 degrees still. It's probably warmed up. So when I plug in, I get 65.638. It keeps going. I'm going to say 65.64 degrees Fahrenheit. So interpret this result. So after 0.6 hours at the beach, which we could see how many minutes that is. You do 0.6 times 60 minutes in an hour and see that that's 36 minutes in. So however you want to say it, 0.6 hours or 36 minutes at the beach. The wine is 65.64 degrees Fahrenheit. No longer a very cool bottle of wine. It was 33 degrees, about a half hour in, 36 minutes in, or 0.6 hours in at the beach. The wine is 65.64 degrees Fahrenheit. So the next part says find T prime of 0.6 and interpret the results. So plugging into the original, however many hours, tells us the temp. Plugging into this derivative is going to tell us how fast the temp is increasing or decreasing. This one's obviously increasing based on the context of the problem, but we are going to get a rate of change when we plug into the derivative. So first of all, we need to take the derivative of our function here. We want to recall how to do this. We have an e problem here. So if you had the derivative of e to the x cubed, remember the rule is to take the derivative of the power. So derivative of just the x cubed is 3x squared times e to the original power. So derivative of the power, e to that original power it had. So there's just a random example off to the side that'll help us conquer this problem. We're going to take the derivative of 88 first. The derivative of 88 is 0. And now this next piece, I'm going to keep that constant multiple, just like we would if it was a derivative of 5x squared. The derivative of 5x squared is 10x because you kept the 5, okay? So we need to keep our constant multiple, negative 55, and then take the derivative of e to the negative 1.5t. So first of all, what's the derivative of the power? Derivative of negative 1.5t is negative 1.5. Derivative of the power times e to the original power. Okay, and so we can plug into this right as it is, or we can multiply this constant out like we would normally, right? The derivative of 3x to the 5th, we would just bring down, keep the 3, bring down the 5, and we'd say 3 times 5 is 15. These aren't as easy to multiply in our head, but we can grab our calculator and do negative 55 times negative 1.5, and we have a positive 82.5 e to the negative 1.5t. There's our derivative that tells how fast the temperature of the wine is changing. And it says to plug in t prime of 0.6. So I'm gonna grab my calculator, I'm gonna plug in 82.5, use that E button and do negative 1.5 times 0.6. Just like that in my calculator, and see how fast the temperature is changing at 0.6 hours. So when we plug into the derivative, I get about 33.5419. So I'm just going to say 33.54. And this is degrees Fahrenheit. It's a rate of change, so it has 2 units. Degrees Fahrenheit per hour. So our interpretation is after 0.6 hours, or 36 minutes, the temperature of the wine is increasing or decreasing. If we got a positive 33 as our slope at that instant, it must be increasing, is increasing by 33.54 degrees Fahrenheit per hour. So 36 minutes after arriving at the beach, there's a bunch of ways of saying this. 36 minutes after we arrive, though, our wine is increasing in temperature by 33.54 degrees Fahrenheit per hour. So the temp is going up very fast. It's getting very hot very quickly. On average, how is the temperature changing in the first hour? So I see the word average, and we're talking about change. Average change means the slope formula. I want to do f of b minus f of a all over b minus a. But normally we have an interval we're given, right? From 2012 to 2018 or something like that. We plug in 2 different years or 2 different hours. This just says in the first hour. So what interval is that on? That is on the interval from 0, the moment we arrive, to 1 hour in. How fast on average is the temperature changing? So we are going to plug in the temperature after 1 hour minus the temperature when we arrive over 1 minus 0 hours. So we'll have to plug into this original equation twice, or maybe not plug in 0 because it gave us that temperature, but we would want to plug into this equation here, 88 minus 55 e to the negative 1.5t. So I'm going to grab my calculator and figure out what t of 1 is. I'm going to do 88 minus 55 e to the negative 1.5 times 1. What is the temp 1 hour in if we leave this bottle of wine sitting? It's going to be 75.727. It keeps going. So I'm going to write down that whole amount or keep it in my calculator. But I also need to plug in t of 0 or read the problem. So I can plug in 0 into the equation, and I'm going to get the same answer as I do if I read the problem. You chill a bottle of wine to 33 degrees. That's our time when we arrive. So I can either plug in 0 to this, 88 minus 55 e to the negative 1.5 times 0. Just in case I'm not sure, I can plug in t of 0 into the equation, or I can just read the problem, because either way, I'm going to get 33 degrees. It tells us that initial temp. If I plug in 0 here, I get exactly what the original problem told me. So we have 75.7278419. I try not to really round until the final answer. 76-ish degrees after 1 hour minus 33 degrees when we arrived over our difference in X's or T's in this case is just 1. So on average, we get 42.73 degrees Fahrenheit per hour. So our interpretation is on average, the wine temp is doing what? Increasing or decreasing if we got a positive answer? The wine temp is increasing by 42.73 degrees per hour in the first hour at the beach. On average, the wine temp is increasing by 42.73 degrees per hour in the first hour at the beach. So we said the instantaneous rate of change at exactly 0.6 hours or 36 minutes in was about 34 degrees per hour. But over that whole hour, on average, it's increasing by about 43 degrees per hour. So the moral of the story is, if you're going to bring alcohol to the beach, you have to drink it pretty fast.